So here we're going to show the results of the accumulation region of the glacier. These are the sampling points. So just to show you a general view of the concentration ranges found on the ice core, snow core. Here you can see that generally you have this fresh snow on top, very low concentration of particulate matter. Then you have snow accumulated during the winter with variability of snow concentration is not homogeneous, so we sample different parts of the concentrated snow. Between those nodes we have concentrated snow corresponding to summer, PM-rich snow corresponding to the summer, right? And at the bottom of that we have the PM-rich snow corresponding to the summer 2015, which, as I previously said, has not only higher PM due to concentration by melting, but also volcanic ashes from Kabuku volcano that fell into the glacier in April 2015. We have that two configurations. And what about the other two sites? We also have albedo measurements. So I'm going to show you that. For a clear sky situation at a zenith of 52 degrees, we measure an albedo of 0.626. It was for fresh snow, right? It's fresh snow. We must say that although the snow has only a few days there, it has already aged pretty much, and the measure grain size, measured with a simple magnifying glass, was about 1 millimeter, or round grain about 1 millimeter. The other nearby site was a slope of the mountain. Due to the slope and winds, there was no fresh snow on top of it, and hence it showed the dark snow surface that we wanted to see on summer on the glacier. So measurements showed a very higher, much higher concentration of particulate matter, of course, and a much lower albedo, right? As it was in an overcast sky, as I said before, we needed to flip fastly the sensor so we can measure upwelling and downwelling radiation for the same incident radiation, right? So how does these measurements compare with model albedo of snow? So far we have only compared with Sneaker online model. It's a widely used model for climate models, and there is a simpler online version that you can use. So for the fresh snow, or almost fresh snow for the first site, we see there's a very good comparison of the simulated albedo and measured albedo, and the uncertainty is mainly on the size of the grain of snow. But for the other side, the comparison is not so good. We get much smaller albedo, but it's not as good the comparison, right? There are many uncertainties here. The concentration of ashes is much higher, the concentration of particulate matter. We simulated it as it were only ashes, but we don't know the chemistry yet, so we have to, maybe that can change the results. And also the deepness, the depth of the layer is very important in this case, as its density. So we need to measure in sight the depth of the layer very precisely, which is not easy because there is a large horizontal heterogeneity of the depth of this PM-enriched layer. Very well. What's left? we need to calculate, we need to measure, analytical chemistry of this particulate matter we collected on filters, so we have many measurements to perform. We're going to compare different techniques to measure the carbon content, black carbon, organic carbon, etc. There is some controversy on this, therefore the difference on the results of the different techniques. We're going to have to address that controversy. And also we need to measure geochemistry of the other elements present, mainly to know the amounts of dust and volcanic ash. But to help with that, we're going to use satellite products, and I'm going to show fastly a few images of that. We can see that satellite images show us biomass burning fires close to Cerro Tronador, so we can see that at some periods we're going to have black carbon and organic carbon deposited very likely on the glacier. And also we can see clearly how the smoke, how the emissions of volcano eruption from Calbuco volcano in Chile in April 2015 reached Mount Tronador. So it's very likely that we will find that too. To make that more certain, we're going to look for correlations between quantitative data from satellite products and compare with event observations, both from satellite image and local observations, so we can be certain of what kind of particulate matter we are looking for different dates on this ice core, right? So that's all I wanted to say today. I hope it was clear enough. I'm waiting for your questions and comments, please. And these are the people that help us with this project.